Hello everybody, so this is just be a quick video going over the main problems that I found that you guys were having with these the redox questions. So let's go through these. They're going to be working through all these. So the first part we were asked what we've got here. For each of the following, combine the two ion electron equations to write the overall redox equation. So this is a relatively straightforward one, but the obvious issue that we have here at the minute is we've got 3 electrons here and 2 electrons on this side. So we can't add these together yet because you need to have the same number of electrons on both sides. So we need to have either 3 electrons here, 3 electrons here, but we don't have that, so we need to do something to both of these equations. So we're trying to get these here to be the same number. So how we can do that is we can times everything in this equation here by 2, and then everything in this equation here by 3. And if we do that, we will get 6 electrons on both sides. So if we times everything here by 2, 2 lots here, 2 lots here, and then that will change to 6. And then for this one here, we times it all by 3, so that changes to 6. That changes to 6, and then that changes to 3. And now we can add these together. So we're going to add all of the reactants here. So it's 2Al plus 6H plus. And for now, I'm not doing the state symbols, but really you should do the state symbols to be fully accurate. We'll stick the electrons in for now. And then 2Al3 plus, so this is all of the products on this side now that I'm doing, plus 3H2 plus 6E minus. But we're not yet finished because we've got the same thing on both sides of the equation. If we've got the same things on both sides of any equation, we can cancel. So they're gone. So to fully rewrite the full correct answer would be 2Al plus 6H plus goes to 2Al3 plus 3H2. Okay, so that there is now our final answer. The key thing to note is you have to get the same number of electrons on both sides, and if you multiply the number of electrons, you also need to multiply everything else in that there, and then finally cancel the electrons, and that should give you a redox equation there. Okay, so next one. This question was write the reduction and the oxidation equations. So we'll just do G first. So what is being reduced, what is being oxidized? Well, if we write out this full equation, so G is here, and this time what I'm going to do is I'm going to put the charges in each chemical, and we'll see how that changes the chemical. So we've got sodium sulfite here. It's an aqueous solution, which basically means that these ions here, the sodium ions and the sulfite ions, they are they're separate, they're not joined together. So we've got 2 lots of the Na plus, and we have, and again, I'm not doing the state symbols just for space, the sulfite ion. H2O is a molecule here, and it's a covalent molecule, so that's not ion, so that's just as it is. And we've got I2 as well, so that's all of our reactants. So these are going to react together. And let's see what happens next. So this goes to Na2, so again, we've got the 2Na plus. And this time it's changed. It's not SO3, it's now the sulfate ion, SO4, 2 negative. And we have some H pluses. And now we've got some 2I negative. So quite a lot has changed here. But something you should notice is that there is one set of chemicals which are the same on both sides. We've got these sodiums here and sodiums here, so Na plus and Na plus. They're the same on both sides. So if something is the same on both sides, basically, in this solution here, in this beaker where this is happening, these sodiums are not doing anything. They're just sitting around watching it happen, which is why they're exactly the same on this side here. We refer to these as spectator ions. So they're not involved. There's no chemistry happening with these sodium ions. They're the same at the beginning as they are at the end. The chemistry is happening elsewhere. And one of the things you should notice is that our sulfate changes. So, or sulfite rather, changes to sulfate. So how do we go from here to here? Well, first off, we've got an imbalance in the number of oxygens. We've got 3 here and we've got 4 here. So we have to add a water molecule, which is this one here. And now we have to add some hydrogen ions. Oops. And now we need to balance the charges. So we'll do this in a bit more detail later on, but for now we can an example of this in a bit more detail later on, but let's just go through this. So what do we have? We've got on this side of the equation, so let's just sort of do a line here. So this side of the equation is 2 negative currently, and this side of the equation it is 2 negative plus 2 positive, so therefore it's neutral. So we need to get this side of the equation down to 2 negative, like so. And now that's 2 negative. So this now is our, well, what's happening is this here is losing electrons, and this therefore is the oxidation equation, which would leave us with, what else is changing? Well, this I2 is going to, iodine is going to iodide. So let's just figure out, how that happens. Goes to 2I negative. So the iodine's atoms, they're fine, they balance 2 here, 2 here. Charges don't though. On this side it's 2 minus, and on this side it's neutral. So we need to therefore get this side down to 2 negative. So we had 2 negative electrons, which are these electrons here. These electrons have left this, and now they're being taken in by the iodine molecule here. And this now is, because this here, we say that this chemical, this iodine, is being reduced. So this is the reduction equation. This is reduction. And this is the oxidation equation. Okay, now, yeah, we don't have any more space to do this one, but the idea is the same. So what's happening here, this is changing into this. Notice we've got 2 plus and we've got 3 plus, and then our dichromate is changing into a chromium ion there. So you would do the same idea, same process there. Okay, next one. Which of the following reactions identify the oxidizing and reducing agent? Okay, let's just have a quick look at this here. What I've done here is I've written a full oxidation equation and a full reduction equation. But now in this question, you're being asked to do oxidizing and reducing agent, right? So you wouldn't be writing a full equation, which a number of you did. So we'll do A and see if we've got space left for B. So basically, you're trying to choose either this or this, right? It's nothing to do with the products here. It's always the reactants. So what's gone on with our Cl2? Well, our Cl2 has changed to 2Cl negative. How's that happened? It's taken in 2 electrons. Okay, and then our 2Br minus, so our bromide ions, they've changed to Br2. Well, how's that happened? Well, we've got a 2 negative charge on this side, neutral charge on this side. So therefore, I mean, if we add electrons here, it goes to 4 negative. So that's definitely wrong. So therefore, we have to add electrons on this side. Our charge is now balanced. So now we have to figure out which of these two is the oxidizing agent, right? So our oxidizing agent here, let's write down. So oxidizing agent equals reduced equals gains electrons. So let's use this to sort of figure out what's going on. Okay, so this Cl2 here, it is gaining electrons, is therefore being reduced. Therefore, this is the oxidizing agent here, which therefore must mean that this is the reducing agent. We can just check that. So reducing agent equals oxidized equals loses electrons, and it has. It's lost these electrons, therefore it's been oxidized, therefore this is the reducing agent. Okay, same thing again with this one. Which of these two here is going to be the oxidizing and reducing agent? So let's just do Mg. What does it turn into? It turns into Mg2 plus. So let's balance this equation. We've got the same number of magnesiums here, but our charge is different. We've got 2 plus on this side, we've got a neutral on this side. Let's balance it by adding 2 negative electrons. Now overall charge here is neutral, overall charge on this side is neutral, so that is good. And let's do the next one, Cu2 plus goes to Cu. So our charge on this side is 2 positive, our charge on this side is neutral, so we need to get this side down to neutral. So let's take those electrons and they can be added there. Again, let's apply this logic here. So the oxidizing agent is the one that's reduced, the one that's gaining electrons. This here, these electrons are being gained by this, therefore this is being reduced, therefore this is the Cu2 plus is the oxidizing agent, and therefore this is the reducing agent here. Okay, so one final thing to note as well, several of you in writing the answers, so let's pretend this is your answer sheet, so identify the oxide, and people would write magnesium. Well, that's wrong. It could be because, are you referring to Mg or are you referring to Mg2 plus when you just write magnesium? So you need to be more specific. You need to say it's either this one or this one, and in this case it would be this one here. Okay, so that's that one, and then coming to the last one. Loads and loads of people got this one incorrect. So this is, can you balance the redox equation? So let's write out iO3 negative turns to I2. First thing you should do is you should balance, we'll refer to them as the parent atom. So this one here, or the main atom, whatever you want to call it, we've got 1 iodine, and here we've got 2. So we need to stick a 2 in front of that. And now we need to balance the oxygen. So 2 times 3 is 6. So we need to add 6 molecules of water. And we've now got hydrogen. So we've got 6 times 2. So we've got 12 H pluses. And now the charges. And it's always the charge. I think if people can get to this stage, the reason why they get it wrong is because the charges are wrong. So let's have a look what we've got on this side. On this side is neutral. We've got no charges at all. And on this side we've got 2 negative plus 12 positives. So in other words, at the minute it's 10 positive. We need to get it to neutral. Therefore, we need to add 10 negative electrons. Okay, so those were the main issues. Hopefully this has been helpful. Please crack on with the questions that are due in for next week, and thank you for watching.